Hey guys, Mr. B here. On this video, we're going to be going over the 26.4 notes. So if you want to just listen to this, and hopefully this will be more like what we would be doing in class. So in this section of the notes, we're going to be going over groups of stars. So you're talking about how stars are distributed in space, what are some characteristics of each type of star cluster, and then we'll be talking about galaxies. All right, so first off, some of you may know that stars up in the night sky can sometimes make patterns, and we call these patterns constellations. We're not really going to be talking about constellations a whole lot in this section, to be honest. Constellations are a little bit more folklore, and what that means is that they're not super scientific. You know, you can kind of connect the dots with stars in kind of whatever way, shape, or form you want to make whatever image you want. So even though constellations certainly have a place in some fields, we're not really going to get a whole lot into them in this. So we're just going to kind of skip past this here. All right, so first let's talk about star systems. So how are stars distributed in space? So most stars, to be honest, are found usually in groups of 2 or more. It's very rare to find a star completely by itself out in space. So most stars are grouped together with 2 or more stars in what we call a star system. And of course, because they're so close and there's a lot of gravity, gravity tends to keep them together. Pretty much like I said, every star or most stars out in the universe are in groups like this. Our sun, our star, which is the sun, kind of being by itself is sort of rare. That's not a super common feature for a star to be completely alone. Usually there's actually 2 of them that come together. So a lot of stars are in pairs like this, and so we call these binary stars. The word bi means 2, like a bicycle has 2 wheels. So these stars typically, again, they come in pairs like this, and they will usually revolve around each other, kind of like figure skaters, right, that are holding hands as they spin around each other because of their gravitational attraction. And as this happens, we can view them from Earth, and what will occur is that as one star passes in front of the other one, it will block off some of the light of the other star, and it will eclipse it. So a lot of times we call these stars eclipsing binaries. And this is partially the reason why we know that most stars come in pairs like this, is because by looking at the starlight that these stars give off, we see that there's times when they're brighter and times when they're less bright, and it kind of goes like this. And every time it does this, that's every time that the star passes in front of the other one, and so some of that starlight gets cut off. So, all right, we're not really going to be answering any of the questions here. I do have a video of me going over the questions, so if you want to know if you're doing them right, you can go check that video out, but we're just going to continue talking about information. So, all right, so moving on from star systems, you move into star clusters. So what is the difference, right? So the main difference between a star system and a star cluster is a star cluster is just simply bigger and has more stars. A star system is usually smaller. There's 3 basic kinds of star clusters. We have open clusters, associations, and globular clusters. Each one is different from one another. The open clusters and associations are a little bit more similar, but globular clusters are pretty different from the other 2. So, so open clusters are typically disorganized, loose, pretty well spread out of a few thousand stars. Usually the stars in open clusters are young and very bright, and there's often a lot of dust and gas around them, so new stars are forming in these clusters. This picture here is of the jewel box open star cluster. If you look at it, it sort of looks like it would be a box of gemstones, right? Because they're all sparkly like that. Associations are usually also loose groupings of bright young stars, but typically they're larger than open clusters and they have fewer stars. So they're a little bit more spread out, but very similar to an open cluster in the fact that it's usually young, bright stars, and there's a lot of gas and dust. So again, again, there's a lot of new star formation going on. Globular clusters, on the other hand, are usually older stars. So in a globular cluster, you're going to have a lot of stars, and usually there's no or very little star formation. There's not a whole lot of gas and dust. A lot of these stars are very heavily packed together. and they're older, right? So this picture here is the 4-7 Tucanae globular cluster. Every single dot that you see in this picture is an individual star. So you can tell that there are a lot of them, right? Now these star clusters here that we're looking at, these are not galaxies. So star clusters are, as they are, literally clusters of stars, but they're not galaxies. Galaxies are bigger than that. We're going to be talking about galaxies here in a second. So again, we're going to skip past this question. You can go watch the video on that if you'd like. So going into galaxies, what are the types of galaxies? So first off, let's talk about what a galaxy is. A galaxy is a huge group of individual stars, star systems, star clusters, dust, gas, planets, pretty much everything that you've ever known about or thought about or know exists in outer space is found inside of galaxies. Okay, there's really nothing between galaxies. There are some stars and stuff kind of floating off by themselves, but very, very minimal. Most things that you can think of in space are inside of galaxies. So galaxies, of course, are very big. They contain everything that we know about in space. Our galaxy, of course, is called the Milky Way, as most of you probably know. And we typically classify galaxies in four main types. So there's spiral galaxies, barred spiral, elliptical, and irregular. Okay, so we're going to go into each one individually. We'll look at, of course, what each one looks like, and more specifically, some characteristics about each one that make them different from one another. So spiral galaxies are basically galaxies where you have a very big group of stars at the center, and then arms that extend outward like a pinwheel. So this is probably the most common galaxy that most people... Long night, I apologize. This is probably the galaxy most people are familiar with. This is, of course, what we believe our galaxy looks like. It's a spiral galaxy. Most spiral galaxies are going to have young stars out near the edges and older stars typically near the center. Also, some spiral galaxies have a bar that runs through the center with arms that then extend outward from the bar. So we call these ones barred spiral galaxies. We have an image here of what each one of these looks like. So this galaxy here to the left would be a regular spiral galaxy. We see that there are trailing arms that kind of spin outwards like a pinwheel with young stars on the edges, old stars in the center. A barred spiral galaxy, as you can tell, looks very similar. We just have this kind of linear line of stars through the middle before then we start to see that spiral. And again, you can see that there's a lot of gas and dust on the edges here where new star formation is occurring, but in the center of both of these is usually going to be more formed stars that are older. So, all right. Moving on here, our second type of galaxy, or third type, I should say, type of galaxy are elliptical galaxies. Elliptical galaxies are typically spherical or oval. They can be more oval shaped or more, spherical shaped, but they're always going to be that shape. They do vary in size, so some can be bigger or smaller. They do not have spiral arms, which means there's very little gas and dust, if any, in them. So there's not a whole lot of new star formation going on. And so, yeah, there's very little new star formation, older stars typically, and again, no spiral arms. So this picture here is of the Andromeda Galaxy. This is the closest galaxy to ours. So this one has been imaged many times because it's very easy to see. Last type of galaxy we have here are irregular galaxies. A very small fraction of galaxies are known as irregular galaxies. So most galaxies, of course, are not like this, but irregular galaxies typically have no discernible shape. So they're sort of like big blobs. Lots of gas and dust, so lots of new star formation occurring. They come in all kinds of different shapes and sizes, but they're usually smaller than other galaxies. And it could be that these galaxies, over time, as gravity works more on them, they do start to take more of a shape and could eventually turn into a spiral galaxy or elliptical one. But as of right now, all we know is that there are galaxies that kind of don't fit either the spiral or elliptical description, so we just call them irregular ones. Now again, our galaxy is called the Milky Way, and the reason for that is not because it looks like the candy bar, unfortunately. It was named the Milky Way well before the candy bar came around. But this is because if you go to a location far away from city lights, you can actually see a very thin band of white that goes across the night sky. And this is the band of stars and other things that you're looking through as you look out through our galaxy. And ancient astronomers used to think it looked like a Milky River, so they called our galaxy the Milky Way. This is part of the reason why we think that our galaxy is a spiral galaxy. Now, as to where in the galaxy are we? We believe that our sun is about 2/3 of the way out from the center. So we're not in the middle, but we're not way on the edge either. We're sort of, 2/3 of the way out from the center. So we think we're in one of the spiral arms as we go around the galaxy and as the galaxy spins. We think that at the very center of our galaxy, and actually every galaxy, there's a supermassive black hole. And we think that that's part of the reason why there's enough gravity to keep all of the stars and planets and everything in the galaxy together. There's other stuff that we think produces gravity that keeps the galaxies together too, called dark matter, but we'll talk about that in chapter 26.5. So for right now, we're not going to discuss dark matter or anything, but yeah, we do believe there's a supermassive black hole at the center of every galaxy, including our own. So now there are some galaxies that are very, very bright. Typically, these young galaxies can have enormously bright centers, and we call them quasars. And the reason why we think that these galaxies are so bright is that we believe there is a supermassive black hole at the center of these galaxies. And so as the light from stars kind of gets pulled into that black hole, not pulled into the black hole, but kind of bent around the black hole, because light can get bent by gravity. So as the light from the stars kind of moves outwards toward that black hole, its gravity can warp the light and bend it, and then it warps it and then shoots it out in kind of two directions, and you get this very bright sort of beam of different light waves, visible light as well as X-rays and ultraviolet rays and stuff. And so this is an image here. This isn't an actual image. This is an artist's rendering of the OVV quasar. But you can kind of see that we think that there's these kind of beams of light that shoot out from these quasar galaxies where the light is bending around the supermassive black hole in the center, and then it kind of gets spewed out in both directions, and they can be way brighter than other galaxies that are even close to being around them. So, all right, so that is primarily it for this section on galaxies and star systems. So it's a pretty short one. Again, if you have questions or want to know about these practice questions, there is a video of me going over them, so I would recommend going and watching that. And otherwise, I will see you in chapter 26.5.